What is parallelogram law of vectors? If two vectors acting at a point are represented as the adjacent sides of a parallelogram, then the diagonal of the parallelogram which passes through the point of application of these vectors represents the resultant vector both in magnitude and direction. Suppose I consider this. There are two vectors. This vector is P and this vector is Q. We have represented them as the adjacent sides of a parallelogram. Now, let us complete the parallelogram. This is the diagonal which starts from the common meeting point. This gives us the resultant vector. This gives us the resultant of P and Q. So we can say R is equal to P plus Q. And as a matter of fact, the triangle law of vector addition is an equivalent form of parallelogram law of vectors or say forces. That means if I consider two vectors P and vector Q, then the resultant vector points along this direction. But if you represent it in the form of parallelogram law, this is P, this is Q, then this is the resultant. So if you observe this and this are the same thing. It is as if the two triangles are completing the parallelogram, right? The resultant has a magnitude given by square root of P square plus Q square plus 2PQ cos theta, and its direction is given by tan alpha is equal to Q sin theta divided by P plus Q cos theta. That means if this is vector P and this is vector Q, then the resultant is somewhere in between, and that resultant has a magnitude as given by this equation, and alpha angle, that is tan alpha, is given by Q sin theta divided by P plus Q cos theta, theta being this angle. So theta is this angle.